A queue is a data structure that has got two ends. So if you like to remember that how pointers work for every data structure, I would say that it would have as many data structures as the number of ends. Like stack has got one pointer because it has got one end. Queue has got two pointers because it has got two ends. So queue has two ends. Conceptually, what goes in first comes out first. It is a queue in box office, it is a queue in whatever, wherever we form a queue. First in, first out. First come, first serve. So when we implement that to an array, I deliberately not have made this array very vertical but horizontal so that we feel like it is a queue. So we have got two pointers, start pointer and pointer. So start pointer, it is used to insert data, and end pointer, it is used to read data. Insert in a queue, insert value, queue.start pointer is equal to value, start pointer is equal to start pointer plus 1. भागते चले जा रहे हैं आगे. ठीक है? Delete from queue. If at any given point, if its start pointer equals end pointer, it means that queue is empty. So if start pointer is equal to end pointer, then output underflow exit, and if it is not, x is equal to q end pointer means x would have the data which is being removed at the moment, and then we increase the end pointer. The good thing is that both pointers are actually going forward. Your book has got two concepts about it. One concept is when one item is removed, rest of the items are moved forward automatically. The other concept is called circular queue, which is not the part of your syllabus, but it was mentioned. Circular queue means when pointer reaches to the end or the start of the array, they go to the other end automatically. See, if there are 4 items, you add start pointer goes forward, then start pointer goes forward, then start pointer goes forward, and now start pointer is at 4th location, which is the last. Then you start deleting data. You deleted data, end pointer goes forward. You delete data, end pointer goes forward. You deleted data, end pointer goes forward. Now they both are at the 4th position, yet the whole array is empty. What should be done? So your book suggests that whenever you delete, bring the whole data 1 position back. You get that? So your start pointer is there, end pointer is at 1st location. You delete it, you go forward, you delete it, but bring the whole thing back. Start pointer 1 back, data 1 back, everything will be settled down. You delete another, bring back. You delete another, bring back. So this way you would always have data at the start of the linked list. Other one is when both pointer reaches at the end, they come back to the start, and this is called circular queue. We don't cater to any of these ideas. We just cater to this idea that when the item is deleted and pointer increases, when the item is added, start pointer is increased. Simple.
Hello.
बंद कर दे, इसकी माइक बंद कर दिया. All right. Okay. Now you get the whole idea. Let's move to the question. Now again, this queue is being implemented as a linked list. You get that? Sure. This is 4.2. Question 6. 4 to question 6. Summer 15. Summer 15, 4 to question 6. Now, no more stack. It is queue. Create queue, add item to queue, remove item from the queue. A queue ADT is to be implemented as a linked list of nodes. Each node consists of data and a pointer to the next node. The following operations are carried out. Create queue. So let's solve these. Now, queue will not be starting from the bottom, it will be starting from the top. Okay? So now, add name Ali and then Jake. This points forward to this. Then Ben. Then Ahmad. अहमद तुम्हारा नाम कैम्ब्रिज को भी पता है, कई बार आ चुका है, तुम पढ़ के नहीं दोगे। वो बेचारों ने तुम्हारा नाम जो है ना पेपर्स में डालना शुरू कर दिया ईमान से। Ahmad, and then we remove. Which one will be removed? Ali. So Ali is removed. ठीक है? And then what we have? Jatinder. ठीक है? And remove name. Now what will be removed? Jack. Now this will be your head pointer and this would be your tail pointer. Are we good? That is how it will be solved. जी नहीं करेंगे। वही तो मैं आपसे कह रहा था कि कुछ भी बोलें आपकी बुक में, मैं इसलिए बोलता हूँ कि जब आप बाद में पढ़ें तो आप कंफ्यूज ना होना शुरू हो जाए ना, इसलिए मैं आपको बताता रहता हूँ कि ये भी है, करना यूं। 0 अभी तो हम उस कंसीडर कर ही नहीं रहे ना उसको, क्योंकि 1 से स्टार्ट हो रही है तो हेड और टेल दोनों वो होंगे ना, फ्री पॉइंटर 1 पे होगा, वो मुसीबत लिंक लिस्ट वाली है। ठीक है, ओके। वही तो हम डिस्कस कर रहे थे कि whenever we reach to that point where we are at the verge of the array, they do not ask further. There are two methods described in your book. One is, which this gentleman just asked me, whenever we delete, we shift the whole thing up so that we always have a space at the end, till. The other one is, like you said, if we would have to add, we would go back now here and our tail pointer will be shifted up. Get the idea? But none of these practices are happening. चलें जनाब, आगे चलते हैं। नेम के साथ लगे हैं बेटे, क्या मतलब? क्या मतलब नेम के साथ? मतलब एक सेकंड, नहीं मैं समझ गया, रुके, मैं समझ गया। आप कहना ये चाह रहे हैं कि एरो ऐसे लगे हुए हैं, वो क्या फर्क पड़ता है यार, एक नोड दूसरे नोड को बता रही है इधर चले जाओ, ये एड्रेसेस हैं, इस पे मार्क्स थोड़ी कटते हैं। ये नोड पॉइंटिंग टू अनदर नोड, दिस हैज नथिंग टू डू विद वेयर टू, you may make it like that, it's fine, it's just one node is pointing to another node. It hurts. Okay. uh, okay. The create queue operation links all the nodes and initializes the 3 pointers that need to be used: head pointer, tail pointer, and free pointer. So इन्होंने, हसन ने मुझसे पूछा था कि हेड पॉइंटर और टेल पॉइंटर क्या होंगे, तो वो 0 होंगे क्योंकि ये 1 से शुरू हो रहा है, ठीक है, जबकि फ्री पॉइंटर 1 पे होगा। So all of the pointers will be pointing to one position down. The last pointer will be pointing to 0 because it is a linked list. And head and tail pointer will be pointing to 0. Free pointer, whereas, will be pointing to 1. Two, three, four, five, 6, 7, 8, 9, 10, 0. Head pointer 0, tail pointer 0, free pointer 1. Clear? इसमें तो कोई इशू नहीं है। Again, Q is an array. New name is the name that needs to be added to the queue. Free pointer is the pointer where we have to add the value. Head pointer is where the whole thing starts. Tail pointer where we will read from. Current pointer where we are at the moment. Now this is same sort as we did with stack, and only we have to take into consideration the method now is Q. Okay? Q has got 2 pointers. So if 1 minute here. If head pointer is equal to 0, is equal to 0, then output error underflow, else, and then towards the end we have to put and if. Now output Q, what? Current pointer. output queue head pointer. Head pointer, yes. We have to start, we have to output from the head pointer. Current node is head of the queue. Current pointer is equal to now head pointer. If only one element in the queue, then update tail pointer. If head pointer is equal to 0, update head pointer. Update head pointer is equal to queue current pointer dot pointer. Update head pointer is equal to queue array current pointer dot pointer. This is exactly same thing happening. Isha, what you asked last time, this is same thing happening here. If only one element in queue, then update tail pointer. If head pointer is equal to 0, then tail pointer, it means what? We have to make them equal. I told you that when head pointer is equal to current tail pointer, it means that there is nothing. If there is just one item that you have removed, they both have to be at the same location. If head pointer is equal to 0, then tail pointer is equal to 0 as well. There was one item, now it is removed, so they both are pointing to the same location, which is 0. If only one element in queue, then update tail pointer as well. They both are 0. Link release to the free list. Queue current pointer dot pointer is equal to free pointer, and free pointer is equal to current pointer then. अगर आपको ये समझ नहीं आ रहा है ना, तो उसका आसान तरीका यही है, एज आई सेड, कॉन्सेप्चुअली एक डायग्राम बना लीजिए, जो होता जा रहा है उसको उसमें अपडेट करते रहें. सो एट द एंड ऑफ द डे आप उसकी कहानी समझ जाएंगे, बट यू हैव टू स्टडी द बुक before you go any further. So I would recommend these 20-30 pages. Just go through those pages before you start revising on your own. ठीक है? Do you have any other paper alongside computers? No? So you have time, no? All right. वापस आओ. One is an item. The situation is that we have gone back to the state when we don't have any item in the list. Queue is empty. If there was just one item, okay, that is removed. Now both head and tail are pointing to 0. Means as in the start, you asked me at the start, if there is no item in the list, I mean in the queue, head and tail would be 0. I said yes, and free